Different accidents, different causes, but all of these accidents do have one thing in common. At some time during the flight, an airplane upset occurred. And there's one other critical thing they have in common. The flight crews did not recover. An airplane is defined as upset if it unintentionally exceeds the parameters normally experienced in line operations or training. Specific values may vary among airplane models, but the following conditions are generally agreed upon. Unintentional pitch attitude greater than 25 degrees nose up. Unintentional pitch attitude greater than 10 degrees nose down. Unintentional bank angle greater than 45 degrees, or even within these parameters, but flying at airspeeds inappropriate for the conditions. Airplane upsets do happen, but they are rare. Because of this rarity, a flight crew that finds itself in an upset situation can quickly be overwhelmed. Causes of upsets vary. They may be caused by environmental factors, by component or equipment malfunction, by human factors, or by a combination of any of these. But no matter the cause, the foundation for recovery is the same. You must recognize and confirm the situation, disengage the autopilot and auto-throttle, use whatever authority is required of the flight controls, and you must maneuver the airplane to return to normal bank and pitch. Once you've entered an upset condition, you probably won't be able to rely on outside visual references. In many cases, you won't be able to locate the horizon. You must plan on interpreting your instruments. And if you are unsure if an instrument is working, such as your attitude indicator, you must confirm your situation through multiple sources. In fact, that's one of the reasons why redundancy of critical instrumentation is built into an airplane. This video will examine specific recovery techniques that you can use once your airplane has been upset. We've asked 3 pilots to help us in this discussion. 3 pilots who've actually been in some of the situations we'll be looking at. The chief test pilots for Boeing and Airbus have a great deal of expertise when it comes to airplanes that fly outside the normal regime. During flight testing, they regularly push their airplanes beyond normal flight parameters. For the purposes of this training, it doesn't matter how or why the airplane entered an upset situation, or what caused it. What matters most is that you understand that your reaction time is limited. In short, if you find yourself in an upset situation, you must act, and you must act quickly and correctly. You must also guard against letting the recovery of one airplane upset lead into a different upset situation.
An upset recovery team, comprised of representatives from airlines, pilot associations, airplane manufacturers, and government aviation and regulatory agencies, developed the techniques presented here. These techniques are not necessarily procedural. Use of both primary and secondary flight controls to effect the recovery from an unusual attitude are discussed.
Your air carrier must address procedural application within your own fleet structure. The upset recovery team strongly recommends that your procedures for initial recovery emphasize using primary flight controls, aileron, elevator, and rudder. However, the application of secondary flight controls, stab trim, thrust vector effects, and speed brakes may be considered incrementally to supplement primary flight control inputs after the recovery has been initiated.
One more thing. The recovery techniques we'll discuss assume that the airplane is not stalled. If it is stalled, it is necessary to first recover from the stall condition before initiating these techniques. At this point, we feel it is important to discuss stall recovery. As a pilot, you hear and use a lot of different terminology when discussing stalls. Stall warning, stick shaker, deep stalls, and approach to stalls. These are all used in daily conversation.
As we said, in some upset situations, you must first recover from a stall before applying any other recovery actions. Now, what do we mean by that? By stall, we mean an angle of attack beyond the stalling angle. A stall is characterized by any or a combination of the following:
buffeting, which could be heavy, the lack of pitch authority, the lack of roll control, inability to arrest descent rate. These characteristics are usually accompanied by a continuous stall warning.
A stall must not be confused with a stall warning that occurs before the stall and warns of an approaching stall. You have been trained to recover from an approach to stall, which is not the same as a recovery from a stall. An approach to stall is a controlled flight maneuver. However, a full stall is an out-of-control condition, but it is recoverable.
To recover from the stall, angle of attack must be reduced below the stalling angle. You must apply nose-down pitch control and maintain it until you have recovered from the stall. Under certain conditions, on airplanes with underwing mounted engines, you may have to reduce thrust in order to prevent the angle of attack from continuing to increase. Once unstalled, continue with the other recovery actions and reapply thrust as needed.
Airplanes that are designed with electronic flight control systems, commonly referred to as fly-by-wire airplanes, have safety features that should preclude the airplane from entering into an upset and assist the pilot in recovery if it becomes necessary. However, when fly-by-wire airplanes are in the degraded flight control mode, the recovery techniques and aerodynamic principles we will discuss are appropriate. Imagine a wings level situation where the airplane pitch attitude is unintentionally more than 25 degrees nose high and increasing. In this case, the airspeed is decreasing rapidly. As the airspeed decreases, the ability to maneuver the airplane also decreases. Recognize and confirm the situation.
Start by disengaging the autopilot and auto throttle.
Next, apply nose-down elevator to achieve a nose-down pitch rate. This may require as much as full nose-down input. If a sustained column force is required to obtain desired response, you may consider trimming off some of the control force. However, it may be difficult to know how much trim should be used. Therefore, care must be taken to avoid using too much trim. Do not fly the airplane using pitch trim, and stop trimming nose down as the required elevator force lessens.
If at this point you cannot immediately get the pitch rate under control, there are several additional techniques which may be tried. The use of these techniques depends on the circumstances of the situation and the airplane control characteristics.
You may also control the pitch by rolling the airplane to a bank angle which starts the nose down, normally not to exceed approximately 60 degrees. Maintaining continuous nose-down elevator pressure will keep the wing angle of attack as low as possible, making the normal roll controls as effective as possible. With airspeed as low as stick shaker onset, normal roll controls up to full deflection of the ailerons and spoilers can be used. The rolling maneuver changes the pitch rate into a turning maneuver, allowing the pitch to decrease.
In most situations, the steps we've just outlined should be enough to recover. Other techniques may also be employed to achieve a nose-down pitch rate.
If altitude permits, flight tests have shown that an effective method to get a nose-down pitch rate is to reduce the power on underwing-mounted engines. This will reduce the upward pitch moment. If the control provided by the ailerons and spoilers is ineffective, rudder input may be required to induce a rolling maneuver for recovery.
Only a small amount of rudder is needed. Too much rudder applied too quickly or held too long may result in loss of lateral and directional control. Because of the low energy condition, use caution when applying rudder.
To complete the recovery, Roll to wings level as the nose approaches the horizon. Recover to a slightly nose-low attitude, check airspeed, and adjust thrust and pitch as necessary.
Now imagine an upset situation where the airplane pitch attitude is unintentionally more than 10 degrees nose low. Recognize and confirm the situation.
In a nose-low, low-speed situation, remember that the aircraft may be stalled at a relatively low pitch, and it is necessary to recover from the stall first. This may require nose-down elevator, which may not be intuitive. Once recovered from the stall, apply thrust. The nose must be returned to the desired pitch, avoiding a secondary stall, as indicated by stall warning or buffet. Respect the airplane limitations of G-forces and airspeed. In a nose-low, high-speed situation, apply nose-up elevator. Then, it may be necessary to cautiously apply stabilizer trim to assist obtaining the desired nose-up pitch rate. Reduce thrust, and if required, extend speed brakes. Complete the recovery by establishing a pitch, thrust, and configuration that corresponds to the desired airspeed. A question naturally arises. How hard do I pull? Here are some considerations. Obviously, you must avoid impacting the terrain, but also avoid entering into an accelerated stall, and respect the aircraft's limitations of G-forces and airspeed.
We've defined a high bank angle for upset as more than 45 degrees. However, it is possible to experience bank angles greater than 90 degrees. In high bank angle situations, the primary objective is to roll in the shortest direction to near wings level. But if the airplane is stalled, you must first recover from the stall. Recognize and confirm the situation.
At high bank angles, you may be in a nose-high attitude or a nose-low attitude. Let's look at a nose-high situation first. A nose-high angle of bank attitude requires deliberate flight control inputs. A large bank angle is helpful in reducing excessively high pitch attitudes. Unload and adjust the bank angle to achieve a nose-down pitch rate while keeping energy management and airplane roll rate in mind. To complete the recovery, roll to wings level as the nose approaches the horizon. Recover to a slightly nose-low attitude, check airspeed, and adjust thrust and pitch as necessary. A nose-low, high angle of bank, requires prompt action because altitude is rapidly being exchanged for airspeed. Even if the airplane is at an altitude where ground impact is not an immediate concern, airspeed can rapidly increase beyond airplane design limits. Simultaneous application of roll and adjustment of thrust may be necessary. Again, disengage the autopilot and auto throttle. In this situation, it may be necessary to unload the airplane by decreasing back pressure or even pushing to obtain forward elevator pressure. Use full aileron and spoiler input if necessary to smoothly establish a recovery roll rate toward the nearest horizon. It is important to not increase G-force or use nose-up elevator or stabilizer until approaching wings level. If full lateral control application is not satisfactory, you may need to apply rudder in the direction of the desired roll. As the wings approach level, use the procedures we discussed earlier for a nose-low situation. Adjust thrust and drag devices as required.
As you've seen, there are specific recovery techniques that you can use if your airplane becomes upset, no matter the type of upset. Nose high, wings level; nose low, wings level; high angle of bank. You must take control of the situation and you must react quickly and correctly. Let's review the nose high and nose low recoveries one more time, incorporating bank angles. Remember, the sequence of application of these techniques will vary depending upon the specific situation encountered. Thorough review of the causes of airplane upsets and the recommended actions you should take will help prepare you to act quickly and decisively should an upset occur.